Welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. Now in this lecture, we are going to see what are the different non-ferrous metals and alloys. So this is continuation of the previous part which we have discussed in the previous lecture, that is different non-ferrous metals like copper, aluminum, etc. Now in this lecture, we are going to see what are the different types of copper alloys and their applications. Now let us see one of the best alloy of copper. So it has wide range of applications. Because of this nature, it is used in many fields of industry as well as in domestic purpose. So the range of composition is from 5 to 45% of zinc. So the base metal is copper. We are going to add 5 to 45% of zinc depending on the application, so that we can get different types of copper based alloys. Now, generally we know copper is a red colored metal which is made up of mostly copper and some impurities are there. So after getting it purified from the source, that is the ore, okay, some zinc is added. Zinc is another metal which is added to copper, so that it will increase the properties and we will get a new metal called brass. We know this brass very much. So brass is used to make utensils and many idols of gods. Now, they possess excellent mechanical properties and are corrosion resistant and are readily machinable. Now this brass, when compared to regular copper, it is very resistant to resistant to corrosion. Okay, general copper used to corrode in the open atmosphere. That is why a zinc is added in order to improve its property like strength, and also it can increase the corrosion resistance. Now let us see what are the different compositions with which we can get different types of brasses. Okay, now we are studying brass. In this, we have different types of brass depending on the percentage of zinc and copper that is added. Now see, the first one is Mont J metal. So here the copper is 9% and zinc is 41%. So this is a typical brass which is used for architectural work, architectural welding rods and condenser tubes, valve steams, etc. These are all made up of this particular Munch metal. Okay, so Munch metal is the one which is mostly used for making of idols. Like so, these having the property of corrosion resistance, so that they can last longer. And also, when these are used for valves and condenser tubes, they can bear high temperatures as well as their corrosion resistance, because they will be subjected to in contact with water or steam. So what happens when water or steam is in contact? Generally, they will get corroded easily. But with the addition of zinc, these are corrosion resistance. And then second one is cartridge or spinning brass. So we know that the bullets of gun, mostly machine guns or etc., they are made up of brass. The shell of these bullets are made up of brass. So that particular shell is made up of this spinning brass or cartridge. It is called as cartridge. Now it contains about 70% of copper and 30% of zinc. Okay, so 30% of zinc makes it it contains a very brass color. Okay, like it is yellowish in color, and it is mostly used for cartridges of machine guns or guns, and tubes. They can be used to make long pipes, and spinning and drawing processes also can be done on this brass. Spinning process is nothing but it is like making thinner and thinner sheets while using centrifugal force. So that is called spinning. And drawing means drawing the copper into thin wires. We can pull the wires while heating or applying some kind of force on it. We can actually prepare the wires which are made up of copper. That is brass, which is a alloy of copper. And then brazing brass. So brazing brass is the one which contains about 75% to 25% of copper and zinc, and this has typical brass color, and it is mostly used for drawing, spinning, springs. Springs are also made up of this brazing brass, and particularly this is suitable for brazing. Now, what is brazing? Brazing is a kind of joining process used for metals which are less melting point than iron. So, when the metals we want to join like copper or aluminum, we have to use some kind of technique like brazing technique, because welding or gas welding or electric welding can be used for iron or the metals which has more melting point temperatures. That is why brazing brass is used as a filler rod for this brazing technique. So that is why it got this name brazing. Now in the coming lectures we are going to see what is brazing and how it is done. Now the next thing is red brass, red color brass. So here the percentage is 85 and 15% of copper and zinc respectively. So this is mostly used for hardware, radiator cores, plumbing pipe, condenser tubes, flexible hoses. So this is how a red brass can be used. So each and every type of brass will have its own applications depending on its particular property. So why this is used in flexible hoses? Because this generally copper is ductile, but when in this percentage zinc is added to copper, what happens? Everything changes. Like copper can bend more easily. It can be converted into bendable pipes. Okay, so that is why red brass is preferred for in some applications. And then high brass. High brass is where we have 66% of copper and 34% of zinc. Now, this has typical brass color. Similar to all of the brasses, they will have same color. Mostly some of them are reddish in color and some of them are golden reddish in color. Okay, so this high brass is used for stamping. Stamping means we can make these metals for stamping technique, like we can stamp coins. Okay, so minting coins can be done with this metal. In olden days, we have coins that are made up of this high brass. Nowadays, it is very costly and it is very less available in nature, so that we have shifted to steel, that is stainless steel. Nowadays, coins are made up of stainless steel only. Okay, so this is also used for blanking. Blanking technique means we can simply mint the coins, drawing the metal into thin wires, spinning is making it into sheets, and then springs also can be made with this high brass, and then rivets and chains can also be made with this high brass. Okay, these are the general applications where this high brass is mostly used. Mostly it is suitable for springs. Okay, and then springs and coins. And then we have last one, low brass. Low brass is where we have 80% of copper and only 20% of zinc. So the color of this is reddish gold. We can simply observe that whenever the percentage of the copper increases, the metal seems to be reddish. If zinc increases, it is more like golden color, reddish gold color. Now see here, this is mostly used for drawing, forming, flexible hoses can be prepared with help of this copper. Now see, these are the different types of brasses, that is alloys of copper when zinc is added. Particularly, we have another type which is called bronze. So bronze is another type of alloy that is made up of copper, but it contains different additive material. Now, in the next slide, we are going to see what are the types of brasses and what are their compositions. Now see here, the first one is manganese brass, and second one is iron brass, tin brass, lead brass, and then aluminum brass. So these are the different types of brass that are available. Let us see the first one, manganese brass. So the percentage of composition for manganese brass is about copper is at 60%, zinc is 30 to 42%, and tin, iron, and remaining materials are less than 1%. Okay, so let us see the properties of this. So it is exceedingly tough when compared to regular copper. The manganese brass is very tough because we have added more manganese to it. Okay, we have very little percentage of manganese here, 0 to 0.5%, yet it is very tough than the regular copper material. And then it has high resistance even in seawater. So this is one important property which makes this manganese brass very suitable for applications, even in marine applications. Okay, when seawater come in contact with any metal like copper, iron, it will get easily corroded. So that is why, so this copper alloy, that is manganese brass, is used when we have to install some copper parts, copper made up of parts. So we should always go for manganese brass because this is seawater resistant, like it is corrosion resistant to seawater. Because seawater contains a large amount of salinity, and the salinity can cause corrosion for any metal. So in order to uh, protect the metal from corrosion, we have to go for manganese brass. And then the third property is, it is very active in reducing the oxides of other metals, an action that is highly useful. So this is the property by which this manganese is corrosion resistant, because it can stop oxidation with atmospheric oxygen. So generally what happens when iron is subjected to atmospheric oxygen, it will simply get oxidized and it forms a layer called rust. So this rusting is the key for the fracture of the metal, like it will make the metal weak. So similarly, copper also has corrosion technique. I mean, there is a concept for corrosion even for copper also, where copper, when it is get in contact with atmospheric oxygen, it will get oxidized and the metal will be corroded easily. So this is how the manganese brass has good properties. And then we have some more properties. In addition to its action as deoxidizer, manganese hardens and strengthens the alloy. So when we add manganese to copper, it not only increases the corrosion resistance, but also it improves strength and hardness. So generally copper is a very soft metal. It has more ductile property. But when we want to use it in a place where we have to load more on these copper particles or copper bars, we have to go for manganese alloy. So when manganese is added to copper, it shows very good properties of high strength and high hardness. So the next property is, in cast form, the tensile strength of manganese bar lies in the neighborhood of 500 mega newtons per square meter. So this is a very good value. 500 mega newtons per square meter is a very good tensile loading capacity for a ductile metal like copper. Even mild steel is also a ductile metal, but when compared to copper, iron is very strong, even in its ductile form, or its mild steel is stronger than copper. So that is why when we want to use copper in the place of iron, it has some applications. Why do we go for iron? Why do we always go for iron? Because iron is cheap. So when compared to copper, iron is cheap and copper is very less available in the nature. So we have to use it only in some particular applications where it is particularly needed. So when we have to use copper, we have to increase its strength. So that is why the tensile strength of this copper brass is 500 meganewtons. So the uses are like this: manganese brass is used for pump rods, like pumping mechanism will be there in IC engines. Those pump rods will be made up of this manganese brass. And then hydraulic arms are made up of this manganese brass. Valves, cylinders, tubes, propellers, nuts, bolts, etc. So some mechanical parts which are related to IC engines and some valves, cylinders, tubes, etc. These are all made up of this manganese brass, because manganese brass is very hard and it is tough. So that is why this can be used in some places where we cannot use iron. And then the second type of copper based alloy is iron brass. So in this brass, what happens? We will add some amount of iron to it. So the general components of any copper are, generally copper will ranges from 50 to 90%, and remaining is always zinc. Zinc is always added to copper to make it more suitable for any kind of applications. So that is why we have different types of alloys made up of zinc, and in addition to zinc, we are going to add some other metal like ferrous or manganese in order to improve its properties. Or zinc is there, next one. Okay, now let us see what is an iron brass and how it going to show different properties. So one of the most widely used alloys of this type is known as delta metal. Okay, so in iron brass, it is mostly called delta metal. Why? Because we are going to see its composition is about 60% of copper, 37% of zinc, and 3% of iron. Also, a little quantities of nickel and manganese are present in this. So mostly we are adding iron. So this is iron based copper alloy. So let us see what are the properties, because iron is a very good load bearing metal. It has very good strength and tensile strength when we compare hardness, toughness, etc. So it is hard, strong and tough. So all the good qualities of iron are brought to this copper. Now it is easily casted also, similar to iron. Where we want to cast it into required shape or size, we can easily do that with the help of this iron brass. And then its tensile strength is about 2/5 greater than brass of similar composition with iron. See here, the tensile strength of this is 2/5 of greater than similar composition with iron omitted. So if we have normal copper mixed with zinc, if its strength is about let us say the strength is about X, so the strength of this, the tensile strength of this is about 5 times. 5 times compared to normal brass. So iron brass is 5 times more stronger than normal brass, normal copper. So let us see some of the uses. It is used for mild steel if corrosion is to be resisted. So we can simply replace mild steel with this iron brass if you want to avoid corrosion. That means if the surrounding temperatures or environment is more prone to corrosion, that is humid and moisture environment, then we should go for this iron brass because it contains corrosion resistive capacity. And then third type of brass is tin brass. So tin brass is one of the most useful metal added to brass, and it increases hardness and tensile strength, but amount employed should not exceed 2%. So see this, in this type of alloy we are adding tin. Tin is a metal which is added to the copper zinc metal. Then it should not exceed 2%. Okay, the value of tin that is added to copper, it should not exceed 2%. It should be less than 2%. And then the properties of this tin brass is it has high strength and hardness compared to normal copper. It has excellent corrosion resistance property. This is the first thing for which we are making alloys of copper, and its tenacity is high and good working qualities. So this is very good workable condition. It has good tensile strength and it has good resistance property, and it has high strength and hardness. So these are the good properties that we obtained by adding tin to copper. And then we have lead brass. In lead brass, it is intended to filling or turning. Okay, so about 1 to 2% of lead is employed to prevent fouling of tools and cause the turnings to break more readily. Lead increases the softness of the brass. So what happens when lead is added to the copper or the brass? It increases machinability. That means when we are machining the object which is made up of this lead brass, we can easily remove the material. The chipping can be done very easily. So that is why 1 to 2% of this lead is added in order to increase the workability of brass. And then we have aluminum brass. So similarly, we will add some amount of aluminum, but it should not exceed 3%. 3% of total composition, and it raises the tensile strength but decreases the ductility. So adding aluminum will increase the strength, tensile strength will be increased, but ductility is somehow decreased. So the product has a deep golden color and resists corrosion better than ordinary brass. So it cast well and may be forged or rolled. Okay. So these are the some of good properties of aluminum brass with which we can improve some properties. Somehow some of the properties may decline. So yet, depending on the particular application, we can use different types of these things. And then we have another set of copper based alloy, that is bronze. See here, bronze is another type of alloy that is made from copper. So we are going to add some other metals to copper so that we will get essential properties. So these are essentially alloys of copper and tin. So the scientific name for tin is SN. So this is how it is represented. So when we add tin to this copper, it shows some more properties. Okay, depending on the application, we'll change the compositions. And let us see the properties of bronze. The tensile strength of bronze increases with amount of tin, reaching to a maximum about 20% of tin. Okay, when we add tin to bronze, that means when we add tin to copper, its tensile strength increases by 20%. Like 20% of increase in the tensile strength can be seen when we add tin to copper. But as tin increased beyond this amount, the tensile strength very rapidly decreases. So it has to be carefully added to copper. Otherwise, the tin itself can act as a mechanism where it will decrease the property of tensile strength. And then we have second type, bronze. So bronze is most ductile when it contains about 5% of tin. Okay, bronze, it is very ductile when the percentage of tin is about 5%. As the amount of tin increases about 5%, the ductility gradually decreases. That is what we are discussing. As cast, the alloy contains 9% of tin, has tensile strength of about 215 meganewtons per meter square. So here we have, if the percentage of tin that is added to copper is about 9%, we can get a strength of 215 meganewton per meter square. And then the bronze containing 4 to 8% of tin is called coinage bronze and used for making coins and metals. So if the percentage of tin is about 4 to 8%, we can use this metal for minting coins like rupee coins. In olden days, we have rupee coins that are made up of bronze and brass. Nowadays, we don't have them. So in most of the countries, they still use these bronze coins. So when the tin is added about 4 to 8%, we can use this metal for minting coins. And then we'll see what are the different types of bronzes that are available. These are modified bronze. So zinc bronze usually contain about 88% of copper, and tin is about 8 to 10%, and zinc is about 4 to 2%. So we are mostly adding copper, zinc, and tin. So these three things are combined to form bronze. If tin is not there, this can be called as normal brass. If tin is there, it has to be called as bronze. So the presence of zinc in the bronze has the following effects. It increases fluidity of the metal, and in this way tends to prevent gas loss in the casting. So when we want to prepare a casting or an object which is made up of this bronze, so we have to go for this modified bronze where the tin percentage is about 8 to 10%. So when 8 to 10% of tin is present, it improves the fluidity of the metal. That means when we pour the molten metal into the casting cavity, it will go inside easily and not forming any gas bubbles. So it also increases strength and ductility. So adding this amount of tin will also increase strength and ductility as well. The specific gravity when cast in sand is about 8.58 and the melting point is about 980 degrees centigrade. So when compared to normal copper, these are very good properties because copper will melt about at 600 degrees centigrade. So we have increased its melting point to 980 degrees centigrade. So this is modified bronze, and then we have phosphorus bronze where we will add some amount of phosphorus, that is like about 8% of phosphorus is added, and by adding this we can simply improve the property. So it produces very beneficial results through activity as deoxidizing agent. So it will deoxidize the copper so that it will not get corroded easily. And much of it is left in the alloy. It may be determined. So when we add 8% of phosphorus into the copper metal, what happens? It improves the oxidation corrosion property, like it won't corrode easily, and remaining percentage of phosphorus will be determined easily. Okay, it can be removed. A hard brittle substance of white fracture containing about 8% of phosphorus is called phosphorus branch. So this is hard and brittle. It is corrosion resistance. It does not have any ductile properties, which is seen in the regular copper. And then we have third type of bronze, that is silicon bronze. So these are copper alloys having 4% of silicon and up to 1% of manganese with small amount of tin, zinc, iron and aluminum. So here we have 4% of silicon. Silicon is like similar to sand. So the sand particles are mostly made up of silicon. So when the silicon is purified and it is added to copper, we will get silicon bronze. So other than silicon bronze, we have manganese, zinc and other materials which are added in very small proportions. These are like present in copper while it is digged from the earth. So these are purified, but however some little amounts of these metals are present inside. So these are obviously not bronze since tin is very small, because we have very small quantity of tin here. So this is mostly cannot be called as bronze. They are available in the market under various trade names. Okay, and these always have strengths of soft steel and at the same time corrosion resistance. So the properties of the silicon bronze are very similar to soft steel, and it is corrosion resistance. However, and these are used for screws, belts, tubings, pumps, etc. So most of the air conditioner vents or air conditioner tubes are made up of this silicon bronze. Okay, this is how it is very usable for in most of the applications related to HVAC systems. HVAC stands for high capacity air conditioning systems. Okay, and then we have aluminum bronze. So this is another type of bronze that is made up of copper, and here the percentage of aluminum is about 8%. So this is the extra element that is added to aluminum along with tin, copper. Okay, we have 8% of aluminum. This is properly called as copper aluminum alloy, and the properties are this alloy has a high strength. It has marked resistant to corrosion. Its melting point is about 1040 degrees centigrade. So the melting point of copper is being increased by adding different types of metals. Previously, we have seen in iron brass, the melting point is about 980 degrees centigrade. Now, in aluminum bronze, the melting point has reached up to 1040 degrees centigrade. So this is very resistant to heat as well as corrosion. Somewhat difficult to cast due to oxidation. So when casting is done, it easily oxidizes when it is converted into molten metal. So it is not good for casting. Okay, so we can simply forge this. And some uses are aluminum bronze is at present most satisfactory copper alloy for die casting since it causes less corrosion of dies than brass. So this is mostly used in die casting where it can be easily prepared because it does not oxidize easily. It is corrosion resistant. So that is why when compared to brass, this bronze, aluminum bronze is very useful when we want to prepare objects that are made up of this bronze. And then it is used in making hot stamping, although it is not easy to work in this respect as brass or manganese. So it is used in making hot stampings like the metal, the base metal which is made up of aluminum bronze can be heated and can be stamped. We can make stamping process on this, although it has some disadvantages because it does not work easy when compared to other metals. And then it is also used in marine work bearing metals in locomotive. Okay, so in marine works and locomotives, this aluminum bronze is widely used because it has many applications when compared to regular bronze because it is corrosion resistant. It can be converted into multiple shapes. So these are the different types of alloys of copper. So far we have seen two types of alloys. They are brass. Mostly two types are there. This is the broad classification. And then we have bronze. Brass and bronze. When zinc is added to brass, when zinc is added to copper, we will get brass. When tin is added to copper, we will get bronze. By adding different other metals, like third metal is added to this brass, so then we will get different types of brasses, aluminum brass, iron brass, etc. And then similarly, while adding different types of metals to bronze, we will get different types of alloys that are called as bronzes. Now that is all for this lecture. We'll meet in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.